This house pays $0 for heat every winter, and in 37 states across America, it is illegal to build. Holmes County, Ohio. I pulled up a gravel driveway just past 7 in the morning. January, the fields were frozen solid. Before I even got out of the truck, I could smell it, wood smoke, faint, already hours old. Not the thick gray kind that means a fire is burning, the kind that means a fire already finished its job. I walked inside. No furnace hum, no thermostat on the wall. The room was 68 degrees. I asked the man who owns the house when he last lit the fire. He was sitting at a kitchen table with a coffee mug he hadn't touched. He looked at me the way people look at questions they find slightly strange. He said, "Yesterday morning, 6 a.m. It was now past 7, the next day, 25 hours. He did not need to. I almost wrote the whole thing off as an old story told well. I didn't because I had a thermometer in my jacket pocket and the number on it did not lie. I spent the next 4 hours in that house with a notebook, checking every room. The feeling I kept coming back to was not amazement. It was something closer to anger, slow, quiet, the kind that comes when you realize something was taken from you before you were old enough to know it existed. This system is not new. It is not experimental. The core principle has been documented for over 4,500 years. Eonto Evans was not a professor. He was a builder working out of a barn outside Coos Bay, Oregon, who tested a modern version at the Aprovecho Research Center and cut his winter fuel use by 80 to 90%. Same house, same climate, same square footage. Before this video ends, I am going to show you a 2022 county hearing in Jackson County, Oregon, where a family was ordered to demolish a stove that tested 20 times cleaner than anything the EPA certifies and replace it with something dirtier. The ruling said in writing that emission measurements did not matter, only the paperwork did. That is not an accident. That is a system working exactly as designed. And the person it is designed to cost money is you. Pull up your last heating bill, not later, right now. Pause this, go find it, come back, I will wait. You have a number in your head. Maybe it is $180, maybe $260. Maybe you have stopped opening those envelopes because the number stopped surprising you and started just making you tired. Here is what that number actually means. The average American household spends $1,800 a year on heat. Not on comfort, not on warmth as something chosen. On the baseline cost of not being cold inside your own house. 1,200 square feet. A thermostat set to $68 and $150, leaving your account every single month from October through March. Over 30 years, which is roughly how long most people carry, a mortgage that is $54,000. $54,000 to stay warm in a house you own. I want you to sit with that number for a second. Not the monthly number, the lifetime number, because the monthly number feels survivable. 150, 180, you adjust. You cut somewhere else, you stop thinking about it. That is exactly what the system is counting on. The moment you stop thinking about it, the payment becomes permanent. You paid for the house. You pay the taxes on the house. You maintain the house. And every winter you write a check to a utility company for the right to be comfortable inside it. Not because there is no other way. Because you were never shown another way. That check does not pay for warmth. It pays for a system that produces warmth as a byproduct of burning fuel as inefficiently as physically possible. A conventional forced air furnace burns at 80% efficiency on paper. That is the number on the brochure. In a real house, with real duct leakage, real on-off cycling, real heat escaping through walls and ceilings, the actual delivered efficiency is closer to 60%. 40 cents of every dollar you spend on gas or oil is heating the inside of your walls, your attic. The air between your ducts and the floor. A conventional wood stove is worse. The box says 75%. The reality, once you account for a real person loading real wood with a door that opens and closes, is 35%. 65% of the heat your wood could give you exits through the flue. You can see it happening. That white column of smoke rising from the chimney is not combustion. That is money. And after all of it, after the bill, after the smoke, after the wood you split and stacked and hauled and burned, the bedroom is still cold. You are standing next to the stove and your wife is sleeping under 2 blankets 15 feet away. That is not a heating system. That is a performance of a heating system. Think about what you actually do in winter. You ration, You close off rooms, you put on a second sweater and call it good enough. You have made peace with the bedroom being 5 degrees colder than the living room because you have never known anything different. The system does not need to be comfortable. It just needs to be familiar enough that you stop asking why. You are not a homeowner in this system. You are a subscription. The answer to that is not a newer furnace. It is not a smarter thermostat. It existed before the country you are sitting in did, and the people who still use it have not paid a heating bill in decades. In the Bronze Age, roughly 4,500 years ago, settlers in the Eastern Alps built their fires differently from everyone around them. Archaeologists excavating sites in what is now Austria and Bavaria found a consistent pattern fires surrounded by dense stone enclosures arranged not for maximum flame but for maximum absorption. The stones were thick. The chambers were enclosed. The design was not for cooking. It was for heating through the night from a single fire lit at dusk. That is the earliest documented version of what I saw in Holmes County. The Koreans called their version the Ondol. It dates to the Goguryeo Kingdom, documented in texts from around 37 BCE, 2,000 years before the forced air furnace was patented. Channels carved beneath stone floors carried hot gases from a fire at one end of a room to a flue at the other. The floor absorbed the heat. The floor released it slowly through the night. Korean families slept on it. Not next to it. On it. Because the surface temperature was never dangerous, it was the temperature of a warm body. The Romans called their version the hypocaust. They built it beneath public baths under villa floors, inside military barracks from Hadrian's Wall to the Syrian desert. The principle was identical: move hot gas through stone, let the stone do the work. I want to stop here for a second because I think this point gets lost when people start listing ancient civilizations like a homework assignment. The reason this matters is not that old things are better. Plenty of old things were terrible. The reason this matters is that these systems were developed independently with no contact between cultures, using completely different materials in completely different climates, and they all reached the exact same structural conclusion. When that happens in science, it is not called tradition, it is called convergence. And convergence means the answer is correct, not because someone decided it was, but because the universe kept confirming it every winter for 4,000 years. On every continent independently across thousands of years, human beings arrived at the same conclusion. Stone stores heat. Metal wastes it. A chimney that lets hot air escape is not a feature, it is a design flaw. That level of cross-cultural agreement is not coincidence. It is the kind of answer that only comes from a very long experiment with very clear results. I didn't know any of this when I first drove into Holmes County last January. I was following a tip from a reader who said, simply, there is a man here whose house does not have a heating bill. Go look. I am not going to pretend I wasn't skeptical. I was. What I found was a farmhouse outside Millersburg, Ohio, with a structure in the living room that looked like a bench. Wide enough to sleep on, warm enough that Jacob, the man who built it himself in 1987 for less than the cost of a used lawnmower, had never once turned on a space heater since. I noticed his dog before I noticed much else. A large gray mutt stretched across the far end of the bench like it owned the thing. Jacob pointed at it by nodding his head, hands stayed in his lap, the way people move when they have been comfortable for a long time. He said the dog had been sleeping there every morning for 11 years. I asked how the dog knew the bench would be warm. Jacob looked at me the way someone looks at a question that does not need an answer. Because it always is, he said. I was not planning to include that detail. But I keep coming back to it, because it captured something that no efficiency rating ever could. The dog did not check a thermostat. It just knew. 11 years of waking up warm had made that corner of the house as reliable as sunrise. The Germans formalized this principle in the 15th century when the forests of Central Europe were disappearing fast enough to constitute a national emergency. Wood scarcity was not a future problem, it was the present crisis of every household and every government in the region. A guild of craftsmen emerged called Hafner, roughly translated as potters of heat. Their product was the Kachelofen, a ceramic masonry heater designed to burn small, burn once, and radiate for an entire day. The Hafner were paid like architects. Their stoves were insured like property. There are surviving records from the city of Nuremberg from 1,000 482, listing the legal penalties for building a Catchalofen without a licensed Hafner because the technology was considered too valuable to leave to amateurs. Mark Twain encountered one of these stoves in 1878 during his travels through Germany. He wrote about it with the kind of controlled enthusiasm he usually reserved for things that made him slightly ashamed of his own country. He called it the most rational heating device ever invented. One firing, he wrote, sufficient for the day, cost nearly nothing, heat constant, and even rather than the American pattern of too hot and too cold by turns. He wrote that in 1878, and when the Amish of German-Swiss descent brought the Catchalofen to Pennsylvania and Ohio in the 18th and 19th centuries, they did not modernize it. They did not upgrade it. They kept building it the same way their grandparents had, because their grandparents' grandparents had already done the experiment and gotten the answer right. The rest of America forgot. The Amish did not. That is not a coincidence. That is a choice, and understanding who made it and why is the part of this story that took me the longest to track down. But first, the physics, because once you understand it, you will never look at a smoking chimney the same way again. Think about a cast iron skillet. Heat it up, take it off the stove, set it on a trivet. 2 minutes later, it is cool enough to handle. The metal gave up its heat fast. That is what a conventional wood stove does. Now think about a stone wall that has been in direct sunlight all afternoon. You put your hand on it at 8 in the evening, 3 hours after sunset. Still warm. The stone held the heat and released it slowly long after the source was gone. That is the entire principle. A rocket mass heater has 3 parts. The first is the combustion chamber, shaped like a J horizontal feed tube at the bottom, vertical heat riser at the top. You load small sticks horizontally into the feed tube. Not logs, sticks, thumb-thick, dry hardwood, garden trimmings, fallen branches. The fire burns sideways through the tunnel and the gases rise. The second is the heat riser, a vertical insulated tube built from ceramic fiber or fire brick positioned directly above the burn tunnel. The insulation traps heat inside the riser. Temperatures reach 1800 degrees Fahrenheit inside that tube. At 1800 degrees, the smoke burns. Not most of it. All of it. The volatile compounds, the particulates, the gases that in a conventional stove exit at 500 degrees and deposit as creosote inside your chimney, they combust completely inside the heat riser. What exits the system is water vapor and carbon dioxide. The exhaust temperature leaving a well-built rocket mass heater is between 90 and 100 degrees. A conventional wood stove exhausts at 400 to 600 degrees. That difference, 300 to 500 degrees, is heat that stayed inside your house instead of leaving through your roof. The third part is the thermal mass. The hot gases travel through horizontal channels inside a large bench built from brick, stone, or cob, a mixture of clay, sand, and straw. The mass absorbs the heat before it exits. Then it releases that heat slowly for the next 12 to 24 hours. The Aprovecho Research Center in Cottage Grove, Oregon, active since 1976, documented a channel configuration in their testing records that almost no one talks about. Route the internal flue in a snake pattern, 2 full reversals inside the bench, and the gases travel 3 times the distance before reaching the exhaust. Exit temperature drops to near ambient. The bench stores heat for 24 hours instead of 12. The additional cost 2 hours of labor and 0 additional materials. On emissions, an independent lab measurement of a well-built rocket mass heater returns approximately 0.12 grams per hour of fine particulate matter. The EPA's maximum for a certified wood stove is 2.5 grams per hour. The uncertified stove is 20 times cleaner than what the government allows as a maximum. Physics does not care what paperwork a stove has. The physics is simple. The real question is, if this works so well, why have you never heard of it? The answer has a name. Several names, actually. In 1902, a young engineer named Willis Carrier solved a humidity problem at a printing plant in Brooklyn, New York. He was 25 years old. He was trying to keep paper from warping. What he invented as a side effect was mechanical air conditioning. He understood immediately that the same principle, moving conditioned air through ducts, could be adapted for heating. In 1915, he co-founded Carrier Engineering Corporation. By 1950, Carrier Corporation was one of the most powerful companies in American manufacturing. Forced air central heating using Carrier's duct technology as its backbone had become the standard system specified in new residential construction. Not because it was the best way to heat a home, because it was the most profitable way to sell one. The distinction matters. A masonry heater is a one-time capital expense. You build it, you use it for decades, and your fuel cost approaches zero if you have access to any wood at all. There is no filter to replace, no refrigerant to recharge, no annual service contract, no monthly utility bill. A forced air system is the opposite. It requires natural gas or heating oil, both sold by companies with their own distribution infrastructure and pricing power. It requires electricity to run the blower. It requires annual maintenance. It requires filter replacement. It requires duct cleaning. And when it fails, which it does reliably between years 12 and 18 of its lifespan, it requires a $4,000 to $12,000 replacement. They sell you the problem and the solution in the same aisle. The trade groups understood this arithmetic before most consumers did. The American Gas Association, founded in 1918, spent the following 5 decades systematically building the regulatory and construction infrastructure that would make natural gas heating the default choice in American homes. By 1960, natural gas was connected to more than 40 million American households. The infrastructure investment made any alternative not just culturally strange, but structurally difficult. When the EPA was founded in 1970 and began developing emissions standards for residential heating equipment, the Air Conditioning, Heating, and Refrigeration Institute, the primary trade group for the HVAC industry, representing Carrier, Lennox, Trane, and dozens of manufacturers, became one of the most consistent lobbying presences in Washington for standards that favored factory-manufactured certified equipment. I want to be precise here, because precision is the difference between a complaint and a case. The EPA certifies residential wood-burning equipment through a process that requires laboratory testing at an EPA-accredited facility, a minimum of 3 test runs per emission, category factory inspection, and annual compliance. Fees. The total cost for a manufacturer seeking certification on a new product design runs between $50,000 and $80,000. If the design changes even a minor modification, the clock resets. A rocket mass heater is built on site. Every one is unique. There is no factory. There is no assembly line. There is no product in the regulatory sense of the word, so it cannot be certified. Not because it fails testing. It has never been tested by the EPA, because the EPA has no mechanism to test something that does not come off a production line. The result is a system where the cleanest residential heating technology in the country, independently lab tested at 0.12 grams per hour, against an EPA maximum of 2.5, is legally classified alongside wood stoves that pollute 20 times as much. Not because of what comes out of it, because of what is not on it. I spent 3 weeks trying to find the counter-argument, the government study showing hidden emissions problems, the safety issue that explained the regulations. I found none of those things. What I found instead was a 2014 Federal Register entry that created a masonry heater exemption covering units weighing over 1,800 pounds that specifically excluded rocket mass heaters from its provisions. The exemption was written in response to lobbying from the commercial masonry heater industry, who are also manufacturers, who also have a financial interest in keeping custom-built, uncertified alternatives out of the legal market. The pattern is not subtle once you see it. In the 1950s, the industry used advertising to make masonry heating seem primitive. In the 1970s, it used regulatory capture to make uncertified heating seem illegal. In the 2010s, it used the exemption process to draw the line just far enough to include commercial masonry heaters sold by licensed contractors at $5,000 to $15,000, while excluding the $50 version you could build in. A weekend. Every generation a new mechanism. The same outcome. I want to be fair here. I do not think the people running these trade groups sit in rooms and laugh about keeping Americans cold. I do not think it is that simple, and pretending it is would make this story easier to dismiss. What I think is more accurate and more disturbing is that no individual decision was ever clearly wrong. Each regulation made sense within its own logic. Each standard solved a real problem. Each exemption was technically justified. The system does not require malice to produce this outcome. It only requires that the people setting the rules also have the most to lose if the rules change. That is not a conspiracy. That is just how concentrated financial interest works when it is given enough time and access. And the 2022 Jackson County, Oregon ruling made the mechanism explicit. A family built a rocket mass heater on their property, 18.7 acres. They hired an independent laboratory before construction was complete. The lab measured emissions at 0.12 grams per hour, well below any threshold in any applicable standard. They submitted the results to the county. The county inspector ordered demolition anyway. The hearing officer's written ruling stated, "Compliance is determined by listing status, not by emission measurements, not by what comes out of the stove, by what sticker is on it." They demolished the clean stove. They installed an EPA-certified stove. They spent $14,000 to do it. The certified stove produces more particulate matter per hour than the one they tore out. It was not buried because it failed. It was buried because it worked. But anger does not keep a house warm. And if you have watched this far, you are not here for the anger. You are here for the fix. So let us talk about the fix. If you already own a house and you are thinking this only applies to people building from scratch, this part is specifically for you. You do not need land. You do not need a contractor. You do not need to touch a single wall of your existing house. Here is what the basic system costs to build. One 55-gallon steel drum, $15 to $25, available at any farm supply store or often free from restaurants that receive bulk cooking oil. 25 to 30 fire bricks, the dense cream-colored kind, rated for high temperature, not regular, red clay bricks, $15 to $20. One metal flue pipe section for the heat riser, typically 8-inch diameter, $5 to $10. Clay from your own yard. Or a 50-pound bag of dry fire clay from a building supply store, $0 to $8. Refractory mortar, one small bucket, $8 to $12. Total, if you buy everything new, $43 to $75. Step 1, the burn tunnel. Set fire bricks on edge to form a horizontal channel, roughly 8 inches wide and 8 inches tall, about 24 inches long. This is where you feed the wood. The bricks need to be tight. No gaps wider than a finger. Use a thin layer of refractory mortar and let it cure 48 hours before your first fire. If the mortar is still wet when you light it, you will crack your bricks. Step 2, the heat riser. The vertical tube rises from the end of the burn tunnel. Cut the top off the 55-gallon drum. Set the drum over the riser upside down. The drum becomes an outer shell. Pack the space between the drum and the riser with perlite or vermiculite, $12 for a bag at any garden store that will do 2 builds. This insulation is what drives the temperature inside the riser to 1800 degrees. Without it, you have a stove. With it, you have a combustion engine. Step 3, the thermal mass. Build your bench around the drum using cob, 3 parts sand, 1 part dry clay, half part straw mixed with enough water to hold its shape. Embed a flue pipe horizontally through the bench before you build around it, making 2 full reversals, the snake path, before reaching the exhaust port. The gases travel 3 times the distance and deposit nearly all their remaining heat into the bench before exiting. Do not skip this step. A straight pipe loses you 12 hours of radiant output. Step 4, the exhaust. Run your exit flue to the outside through a wall rather than a ceiling to keep the exhaust path short. The exit temperature will be close to room temperature. Use a moisture-resistant flue liner if you have one. Step 5, the first fire. Small dry sticks, thumb thick. Start with a handful of newspaper and build up slowly. Within 2 to 3 minutes, you will hear a low roar from inside the riser as the updraft establishes. That sound means the system is working. Feed sticks steadily for 45 to 90 minutes. Then stop. Let it finish on its own. I did not mention that I failed the first time I tried this. I got the feed tube geometry wrong, made the horizontal section 2 inches too wide, and the draw never established properly. I spent 3 hours adding wood and wondering why the riser stayed cool. When I figured it out, I re-bricked the tunnel in an afternoon. The second fire worked in 4 minutes, 2 inches. I tell you that not to discourage you. I tell you because every person I have spoken to who built one of these, David in Medford, Jacob outside Millersburg, a retired school teacher named Rose in central Vermont, who heats a 1,200 square foot farmhouse on wood. She picks up by hand every single one of them made at least one mistake on the first build. And every single one of them built a second one that worked. The learning curve is 1 weekend long. Now, about that family in Jackson County. The one ordered to demolish the stove that tested 20 times cleaner than EPA standards. I reached out to them after the hearing. They rebuilt. Not in the house, in an outbuilding adjacent to the house where residential code enforcement does not apply in most rural Oregon jurisdictions. They ran a simple hydronic loop, a coil of copper pipe inside the bench, connected to a small water tank and circulated warm water through a radiator in the living room. Their heating bill last winter, $0. Same family, same cold Oregon winters, different wall. His name is David. He lives outside Medford. He told me the only thing he regrets is not building it sooner. He said the county could have the certified stove, he had the warm house. David is not an anomaly. He is what happens when someone stops asking permission to do what worked for 4,500 years and just does it. His certified stove sits in the corner of his garage unused. His bench is warm every morning before he wakes up. That is not a theory. That is Medford, Oregon last February when the temperature outside was 19 degrees and the inside of his house was 71 8 hours after the last stick burned out. The principle behind that warmth is not new. It was documented in Austrian mountains before the Roman Empire existed. It was refined by Korean builders 2,000 years before the first American furnace was manufactured. It was carried to Ohio by families who understood that some knowledge does not improve with age, it just persists or it disappears. The people who had the most to gain from making it disappear spent 50 years and billions of dollars doing exactly that. Not through force, through advertising that called it primitive, through regulation that called it uncertified, through a market structure that made the monthly bill feel like gravity, invisible, inevitable, just how things are. It was not buried because it failed. It was buried because it worked. If you are someone who believes that useful knowledge belongs to the people who need it, not to the industries that profit from withholding it, you already know what to do next. Subscribe and leave your state and your average monthly heating bill in the comments below. One number. That is it. I am reading every single one. I am building a map of what this system could return to the people it was taken from. In the next video, I am going to show you a 1,938 USDA document that was pulled from public library circulation in 1954. It covers water, specifically how to produce clean water from a closed-loop system that requires no filter, no chemical treatment, and no municipal connection using a principle first documented by the Aztecs in the 14th century. The agency that ordered the document removed cited public health concerns. The document itself contains no health hazard. It contains a method so simple that a hardware store and 1 weekend is all that separates any household from water independence. When you see that, this video will start to look like the introduction to a much longer story. One last thing. When I drove out of Holmes County that January morning, past the frozen fields back onto the state road heading west, I kept thinking about Jacob's dog. 11 years of waking up in the same warm corner. Not because anyone adjusted a dial, not because a compressor cycled on somewhere in a basement, because a man built something with $50 in a weekend, and then the physics took over and never stopped. The bench was warm this morning. It will be warm tomorrow. That is all heat was ever supposed to be.